Let us start the topic MOSFET. The long form of MOSFET is metal, oxide, semiconductor, field effect transistor. And in FET, the earlier part was JFET. We have already finished it. And the latter part is MOSFET. We are about to get studied. And in MOSFET, there are two types, depletion type MOSFET and enhancement type MOSFET. And first we are going to start the depletion type MOSFET. So first let us see the depletion type MOSFET's construction. The construction consists of a P-type silicon bar, which we call it as substrate. And it is referred as a P substrate. Since it is P material, it is a P substrate. And on one side of the P substrate, we are going to diffuse two N-doped regions. And one of the doped region is source. We are going to take out a terminal from the bottom doped region, that is source. A metallic contact is taken out, that is source, and one more N-doped region. From that we are going to take out one more metallic contact, which is referred as drain. And these two N-doped regions are connected by one more N-type channel, and this is referred as N-channel. N-channel is going to join the two N-doped regions, source region and the drain region is connected by the N-channel. And after that we are going to put the layer of SiO2. SiO2 is nothing but silicon dioxide layer. So we are going to put the silicon dioxide layer. Silicon dioxide is an insulator. That insulator is overlapped on the top layer of the semiconductor material. And above the SiO2 layer, the gate metallic terminal is taken outside. So what you are going to see now in the construction is this is the terminal side. All these metallic terminals are there. After metallic terminals are over, you are going to have the oxide layer, then a semiconductor part. So metallic terminals, oxide and semiconductor. Metal, oxide, semiconductor. Hence the name metal oxide semiconductor, means metallic part, oxide layer part and semiconductor. Hence it is referred as metal oxide semiconductor MOSFET. And this SiO2 layer is going to be there between the two conductors. One is the gate terminal, the other is the semiconductor part. So semiconductor is also a conductor. Between two conductor, one SiO2 insulator is there. Insulator is nothing but the dielectric. Hence we are going to have the capacitor action formed between the two metallic parts. These are the two metals and this is the dielectric. So it is going to act as a capacitor. And we have seen that the three terminals we have taken, the metallic terminals are taken for source, drain and gate, and one more terminal is taken out. One more metallic terminal is taken from substrate outside. This is denoted by SS. And since SiO2 is an insulating layer, this semiconductor is also referred as insulated gate. Gate is insulated from the semiconductor. So insulated gate MOSFET. So this is also referred as insulated gate FET. IG FET is the other name of this MOSFET. MOSFET's other name is IG FET. The other name of MOSFET is insulated gate FET or IG FET. And the construction you have understood. Now we shall go towards the operation and characteristic of MOSFET. And particularly right now we are seeing the depletion type MOSFET. Its basic operation and characteristic we shall see. First, to understand the operation, we are going to have the VGS applied with 0 volts. And next we are going to apply VGS negative voltages, means less than 0 volts. So we are going to see under two cases. First case is with VGS equal to 0. The other case is VGS less than 0. Now with VGS equal to 0, we are going to apply the VDS by varying the VDD supply. The VDD supply is going to give VDS voltage, the voltage between drain and source. And as VDD increases, that is as VDS increases, more number of electrons are going to start moving towards the drain and collected by the drain. Hence, the more amount of drain current flows. So, as VDS increases, as the voltage between drain and source increases, the current ID also increases because more number of electrons are collected by the drain. And this is the case with VGS equal to 0. Now let us see the case, the second case, VGS less than 0 means negative VGS voltages. If applied, what happens? If negative voltage is applied to gate, then more number of electrons are pushed towards the substrate. As electrons moves towards here, the holes in the substrate region are attracted by electrons. So when electrons and holes meet together, they are going to recombine and they become neutral. Then we are going to have this electron vanished when recombined with a hole. So whenever recombination happens, we are going to lose the electrons in this N-channel region. So number of electrons are less means the ID will be reducing. Less electrons means less current. So the current is going to decrease when we apply the VGS equal to negative voltage. So first we have tried with minus 1 volt. When VGS is equal to minus 1 volt, when compared to VGS equal to 0 volt, ID is reduced. And if you go on increasing VGS in negative direction, let us put minus 2 volts, again the ID decreases. So this is being shown by the characteristic curve, and this is a kind of drain characteristic as we have seen in JFET. The drain characteristic is plotted ID versus VDS. So first case is with VGS equal to 0. This is the characteristic plot similar to your JFET, and with VGS equal to minus 1 volt like in JFET only, you are going to have one more curve with ID reduced. If VGS still increases, the curve one more curve is going to be appearing here, and its ID is still lesser. So as you go on increasing the VGS in negative direction, you are going to have smaller amount of ID flowing. And this is your transfer characteristic, and in transfer characteristic we are going to plot ID versus VGS. And we have seen now that VGS is applied with 0 volt or negative volt. This is the characteristic. We can operate the depletion type of MOSFET in enhancement mode also. Means we can apply VGS positive voltages also. If positive voltages are applied, then still ID current increases. So from this point to this, it is referred as enhancement mode, and from this point it is referred as depletion mode. This side it is enhancement mode. And when compared in the drain characteristic, lesser than VGS equal to 0, this area is depletion mode area. And if you apply the VGS positive voltages, we are going to say that depletion type MOSFET is entering the enhancement mode. You are going to have the curves higher than the VGS equal to 0 volt. So if you apply VGS equal to plus 2 volts, you may get the curve higher than this. So we are going to have two modes. One is depletion mode less than 0, for VGS less than 0, this area, and for VGS greater than 0, this area, we are going to have enhancement mode. So the same is being said, depletion type MOSFET, the first type of MOSFET that we are seeing, it can operate in depletion mode as well as enhancement mode. Depletion mode means it is VGS equal to 0 or less than 0, negative VGS. If positive VGS are applied, the enhancement mode. So this is depletion mode, this is enhancement mode. This is what we have talked in drain characteristic. The same can be said in the transfer characteristic. This is depletion mode with VGS equal to negative volts. And with VGS equal to positive voltages, enhanced mode we are going to come across. So this is all about the D-type MOSFET, and the same equation that we have seen with respect to JFET, it is going to hold true. ID equal to IDSS into bracket 1 minus VGS by VD. So here VGS is a negative voltage or 0 voltage. And one more thing is enhancement mode. In enhancement mode, we are going to have ID equal to the same equation, but VGS is positive now. Note, the VGS is positive. So now let us talk about the symbol of depletion type MOSFET. It does have a gate terminal indicated here. This is the channel, and on two sides, on bottom side source terminal, and on in the top side drain terminal, and one more terminal is there, substrate. And if arrow mark is inside going, it is N channel, and if on substrate the arrow mark is outgoing, it is P channel. And sometimes you can show the substrate shorted with source also. So this is the depletion type MOSFET. In depletion type MOSFET, this channel is a solid line. If at all you come across one more enhancement type MOSFET, this is a broken line, and channel line is a broken line in the symbol. And next we are going to see enhancement type MOSFET.